Welcome to numerical series of power plant equipment. This question is asked in 2024 spring of Pokhara University, and the numerical problem is a Francis turbine with an overall efficiency of 75% is required to produce 200 horsepower. It is working under the head of 10 meter. The wheel run at 150 rpm and the hydraulic losses in the turbine are 20% of the available energy. The peripheral velocity is equal to 0.25 root under 2 g's and the radial velocity of the flow at inlet is 0.95 root 2 g's. Assume radial discharge. Determine the guide blade angle, the wheel angle at inlet, diameter of wheel at inlet, and width of the wheel at inlet. First of all, write all the given data. And the given data is overall efficiency, already given in the question, 75%. And power. Power is 200 horsepower. So we multiply the power by 746. And by multiplying this, we can get 149200 watt and divide by 1000. That is 149.2 kilowatt. And the head is 10 meter. Peripheral velocity is CBL is given 0.25 root under 2 g's, and the radial velocity of flow at inlet is CF1 equal to 0.95 root under 2 g's. Wheel speed is already given 150 rpm. Since in the question already said that discharge is radial, assuming radial discharge. So since the discharge at outlet is radial, that is CW2 equal to 0 and CF2 is equal to C2. And hydraulic losses in the turbine is 20% of the available energy. So CBL already given in the question 0.25 into root under 2 g's. The value of g is 9.8 into s is head. Head already given 10 meters. So by multiplying this, we can get 3.50 meter per second. And CF1 is already, this is also given in the question, 0.95 into root under 2 g's. And the value of g is 9.81 and head is 10. By simplifying this, we can get 13.30 meter per second. And the hydraulic efficiency is given as total head at inlet minus hydraulic losses upon head at inlet. S minus hydraulic losses is 20%, so 0.2 S upon S. By simplifying this, we can get 0.8. Now we know hydraulic efficiency equal to CW1 CBL1 upon GS. We had already defined hydraulic efficiency 0.8 CW1 into CBL1 already defined 3.05 upon the value of G is 9.81 and the value of S is 10 meter. Then from above we can get the value of CW1, that is 22.42 meter per second. And this is the figure of Francis turbine. And our first thing is to find the guide blade angle, that is alpha. And from the figure, tan alpha equal to, that is alpha, and tan alpha equal to CF1 upon CW1. As we know, tan theta equal to P by B. From this right angle triangle, we can get tan alpha equal to CF1 upon CW1. Then the value of alpha is 30.69 degree. Similarly, wheel van angle at inlet theta and tan theta equal to CF1 from the triangle CF1 upon CW1 minus CBL1. Putting the value of all this, we can get the value of theta 35.06. Similarly, diameter of the wheel at inlet D1. We know the formula CBL equal to pi d n upon 30, and we have to find the value of D1. So putting all these values, the value of CBL1, value of n, then we get diameter, that is diameter of wheel at inlet is 0.445 meter. Similarly, width of the wheel at inlet, that is B1. And as you know, overall efficiency is equal to power upon WQS, and overall efficiency given in the question 75%, so 0.75 upon power 200 horsepower. We can convert 200 horsepower into kilowatt, that is 149.2 upon 9.81 into q into 10, and q is the distance. So the value of, by simplifying this, we can get the value of q 0.20 meter cube per second. And we know q equal to pi d1 b1 cf1, and we have to find the value of b1. We have to find width of wheel at inlet, that is b1, and putting the value of q d1 cf1, we can get the value of b1, that is 0.108. Guys, if you are not subscribing our channel yet, please subscribe and press on bell notification to get each and every notification on time.